The XOR problem. It looks simple. Inputs are 0 or 1, and we want to output 1 only if they are different. But surprisingly, a single artificial neuron cannot solve this. Today, we're building a network that can. Here is our brain. 2 input neurons for our data, a hidden layer of 4 neurons to capture complexity, and 1 output neuron. Ideally, we want this output to turn green, 1, for mixed inputs, and red, 0, for matching ones. We're using Python and NumPy logic under the hood. Here, we initialize our weights randomly. Notice the messy web of connections? That's our network starting with 0 knowledge. Let's feed data through it. Watch the signals flow. Input times weight plus bias passed through a sigmoid activation. Right now, it's just guessing random garbage because we haven't trained it yet. This is where the magic happens. We run the training loop. We calculate the error, the difference between our guess and the answer, and backpropagate it to update the weights. Watch that red line. That's our loss, or error. As it drops, the network is learning. It's adjusting those connection strengths, visualized by the changing colors, to minimize its mistakes. And there we go. The error has flatlined near 0. Look at the predictions. 0, 1 is nearly 1. 1, 1 is nearly 0. We've successfully taught a pile of math to solve logic. Thanks for watching.